कोई बीच में छोड़ के NHI का मीटिंग जाना है 5:45। तो आजकल मीटिंग ही मीटिंग होता है, काम तो कर नहीं पाते।
बस मीटिंग से ही काम होता है।
तो चक्कर है। Let us hope he joins.
I have sent him again.
Okay. I have Zoom installed, so the link doesn't work, but neither does the meeting ID password.
एक्चुअली रूही तेरे को ब्रॉडकास्ट करना पड़ेगा, क्योंकि मेरे साथ भी वही हो रहा है कि लिंक अलग जा रहा है और ये अलग जा रहा है। तो जब तू ब्रॉडकास्ट करेगी देन यू कैन मेक स्पीकर एंड पैनलिस्ट।
और वो कीप दैट स्लाइड, प्रेजेंटेशन वाला ओपन किया। Yes.
Can I do the broadcasting?
Yeah.
Okay. Okay, no problem.
We can do, na sir? Vinay sir, we can broadcast, right?
हाँ, broadcast तो कर दीजिए. Only I
Yes,
hope that David is able to join. He's facing problems. You have sent the panels list link, na?
Yes, sir.
Okay, then why is he?
Just now also, I just resend again. Sir, he's showing in the attendee list. I'm just promoting him for.
Okay, okay, promote him. He's joined from a wrong one. Doesn't matter.
Good evening, everybody. We will begin our session in few minutes.
Let us see when Mr. David gets promoted.
Yes, sir. Done. He's there.
Can we have the normal square view? If we for 5 minutes we can talk to him. It means if we remove this picture. Yes, yeah. Mr. David.
Hi, Vinny. Can you hear me?
Yes, I can hear you. Can we see you as well? I think you're. Yes, we can see you now.
Yeah.
So sorry for this glitch. Sometimes people do have it. And we just thought we'll see each other first before we begin with the session. You, in fact, joined as an attendee.
Yeah, at the moment I'm signed in via my iPad because my computer won't work. So
that's not the main issue. But when you joined in the category of attendee. Maybe you used one of those links which goes to attendees. So then from there we promoted you to panelist.
Okay.
Okay, but never mind. If I show you some people here, do you see a name, Engineer DG Devte?
Yes. Right.
DG Devte, he is the Director General of IIBE.
He's not in the chair. May come.
Yeah, I think his picture is not visible. Then I'm of course there anyway, you know. Then you see Dr. Gopal Rai. Gopal Rai.
Scouting.
Yes.
Yes.
He's honorary secretary. Engineer Swapnil Joshi. Of course, Dr. Gopal Rai, he's into repairs and rehabilitation, let me tell you, of bridges and buildings. Then you see Engineer Swapnil Joshi. They are into project management, Primavera and all those kinds of things. And they've also made these mobile apps for monitoring projects. Then if you see Indian Institution of Bridge Engineers, this lady, she is Ruhi, R-U-H-I, and she's a lawyer. So we are normally scared of her. And she works with Dr. Gopal Rai. Then if you see another lady, Engineer Deepika Singh, She works with Mr. Swapnil Joshi into the project planning and implementation. Then you see Mr. Umesh Rajesh Shirke, whose picture you must have seen in the brochure. He's a leading consultant of Mumbai, and they design a few extra dosed and cable stayed bridges apart from regular types of bridges. And he's the panelist today. We thought that there should be somebody to pull your leg, so he's there. And of course, he has read, I heard he's read a lot about Humber Bridge.
Not lot, just on Wikipedia and a few websites.
Right.
Yeah.
Okay, good.
So now I think, Deepika, we can put it on the view that we had earlier.
Okay, sir.
Yes.
And you see one named David Josefa. Mr. Josefa is an IT expert who is managing the IT part of it.
Okay, nice to meet you.
Deepika, I think you can now.
Good evening, everyone. We welcome you all to IIB's lecture series. Today we have with us is Engineer David Bishop, who will be presenting on design and testing for replacement of hanger cables of 2,220 meters long Humber suspension bridge. I may now request Madam Ruhi to please present the guidelines.
Thank you, Deepika. Good evening, everyone. Before we start the event, I would like to read basic rules and guidelines for all the participants. All participants will remain on the mute mode during the lecture. Questions should be put in the question answer stroke. After the lecture by the speaker, question will be replied by the speaker panelist. Subsequently, attendees can raise hand below the option at screen. During questions, specific participants will be unmuted by the organizers. After a participant's question gets over, the participant should mute himself. Participants' video will not be displayed on the screen. Speaker, panelists can share screen. Now, I would like to introduce our Honorary Secretary, Dr. Gopal Rai, our host for the day. Dr. Gopal Rai holds a PhD from IIT Bombay. His phenomenal level of progress has enabled him to be associated with several prestigious projects, including the Akshara Reactor BARC, Mumbai Airport Bridge Strengthening of T River, ESIC Hospital, JNPT Rock Bridge, and many more. He is an Honorary Secretary of IIBE, General Secretary of Association of Structural Rehabilitation, and Retrofitting Committee member of ISSE Mumbai Center, BIS, and ACI. He delivered 680 presentations nationwide and 27 presentations in international conferences. He is also a keynote speaker and author in 4 international conferences and many more than 10 national conferences. Dr. Gopal Rai has a colossal research profile as well. More than 100 numbers of his research papers have been published in journals. Dr. Gopal Rai got the award for 50 Manufacturing Innovative Leaders at World Innovation Congress Award 2019. Also in Dubai for 40 Most Influential Leaders under 40 years 2017-18 by Asia One and many more. Now I would like to hand over to Dr. Gopal Rai.
Thank you, Ruhi. I think I am audible.
Yes.
Yeah.
Yes.
Yes.
Thank you very much for a very good introduction. Now it's good to welcome you all officially. Sorry for not stationed in one place. If I get disconnect or anything, we should give credit to Mumbai traffic. Okay, and the full credit goes to Mumbai. A good rain and good weather, and we can see a good weather in Mumbai. And welcome to the today's speaker. Really, it's good to learn a very specific thing. Now, let me introduce the IIB, the founder, and our beloved engineer MC Bide sir. Really, I think profile you can go through on the slides. But one thing I remember always, he always used to say, IIB should do the romance with bridges. So his passion was like bridge engineering should be like go to the all bridge engineers and let us take the good data, and we should the things with the eminent bridges which are constructed worldwide. Series only it is his dream that IIB, now it is 28 years of IIB and more than papers are there, and really it is his contribution, you can say, his wholeheartedly he has served for 30 years, and still he is not there with us, but his blessings are there. That's why the IIB is flourishing like anything, and in COVID condition also we have done a good job. Let me go introduce to our Director General, Engineer Duteji. Rui, can you go to the next slide? Yeah.
Yes,
Director
sir.
General, retired from Indian Railway as a PCE. He's engineer from COP College of Engineering, Pune. And let me tell you about Engineer DG Dute Saab. Always, for any decisions, he always takes pause. But after 2 minutes of pause, he is very firm on his decisions. So, like such kind of eminent the Director General, in his guidance and in his blessings, the things are going in a very positive direction. And he always supports the young generation, and he always encourage for the doing lot of things, activity. And he is the next person after Bide sir with whom we take a lot of guidance, and we encourage. He encourages a lot in the lighter moment also. Thank you very much, our Director General, DG Duteji. Thank you very much. Next to our President. Vinay Gupta ji, one of the stalwart in bridge engineering from TCPL, having the bridge engineering experience from last 30 years, more than 30 years, and a lot of all kind of structures he has designed in the bridge engineering. Let me give a short introduction on the IIB as a president. If today IIB is in English, we can, in Hindi we can say Junodhar. Junodhar means after Bide Saab left, something has been revamped and something has been reconstructed in IIB forum is only because of Vinay Gupta ji. He has put a lot of discipline, lot of activities, and he really give like the number of hours, and he organized the things, and he trained us, the young comers like me and Swapnil. Thank you very much, Vinay Gupta ji. It is a pleasure. Okay, like as a president, and we take all guidance. Next, Ruhi.
Thank you.
Engineer Swapnil Joshi. I think the Swapnil field is in a project planning, and today is in COVID condition. Somebody is who is controlling the site sitting at home, and he has developed a lot of apps, lot of monitoring system, so that you don't have to run to the site for everything. Everything will be at your desktop. So this is the engineering he has learned from NICMARC, and he's from last 8-9 years. He's doing a project planning for eminent projects in India, Dubai, and all South Asia countries. And really he has developed his own tools in COVID, so that minimum hindrance and minimum interference of manpower or anything will be there, and smoothly you can do your all infrastructure projects on time and before time also. So I think this kind of credit goes to Intento, his company name. And really, as a secretary, yes, of course, for any, before I take any suggestion from the bosses like president or DG, my first call goes to my secretary, our own Swapnil ji, and always positive reply. Yes, we can try. That's the best part of the Swapnil. Thank you, Swapnil. I think now it's my duty to hand over to Swapnil. But before that, I want to say one thing. Like, this is the IIB is the forum for the new young generation. So I request a lot of people should become a member. That is the best part. And you should join IIB as a member. And we need a young hand. Okay. And you can access to all paper and everything. Now, Swapnil, I hand over to you. Thank you, Swapnil.
Thank you, Gopal, for a quick introduction. And I formally would like to welcome all the participants, panelists for today's interesting session on replacement of hanger by Engineer David Bishop. So, and today we are having a very specific topic, and we do have a very eminent panelist who is joining us for today's session. So let me introduce the panelists first. So we can you just go to the next slide, please? Yeah. So Mr. Umesh Rajshrike, a very well-known consultant a designer, I would say, with rich experience over 30 years in the planning and design of bridges, flyovers, large span steel structures, marine facilities, industrial structures, pre-stress and reinforced concrete structures, etc. He graduated from VJTI in 1987 and did his master's from IIT Madras in 1991. He was involved in designing of many prestigious structures like cable-stayed bridges in rivers Mahi, Mapusa, Ambura, Bhopal, Patna, Vadodara, and many more. Number of precast segmental bridges, metro rail viaducts, long span steel truss and arch bridges, where his involvement is there, and still he is working on those items. He is a member of various BIS and IRC committees and published number of papers in national and international conferences and journals. So I may welcome our panelists for today's session. So thank you for sparing time and accepting our invitation as panelists. Thank you very much. So now let me go to the next slide for introducing our speaker. What I'll do, I'll request Umesh Ashirke to just introduce. I'll just quickly do a formal introduction, and then I'll hand over the session to you to take it forward. So today's speaker, Engineer David Bishop, Principal Engineer, Design Consultancy Firm, Atkins. He is going to speak today on design and testing for replacement of hanger cable of 2.2 kilometer long Humber suspension bridge. David is the principal engineer for design consultancy Atkins, where he has provided experts advice for the structural assessment and maintenance of some of the largest bridges in the United Kingdom, including the 4th Road Bridge, Humber Bridge, and M48-7 suspension bridge. His experience includes the design and construction for a post-tension concrete bridge built by the balanced cantilever construction method. He is chartered with both the Institute of Civil Engineers and the Institution of Structural Engineers. With this brief introduction, may I now request our today's speaker, Engineer David Bishop, to take over this, the forum and start with his presentation.
Well, this is Vinay Gupta here. While the speaker sets up his screen and other things, first of all, I'd thank the other people also who have joined later on, the eminent dignitaries, Mr. Ravindra Goyal, Mr. Manjure, and of course many others. I just want to share with you how the whole story went regarding this lecture. I contacted the HOD Civil Engineering of Atkins, Mr. Chris Handy. And Chris Handy replied after a while saying that, look, Vinay, I just returned from my 2 weeks of annual leaves, and therefore I'm too tight pressed with the time, but I certainly will spend time on a lecture with you after a while. Presently, he gave some options, and then he gave us one option from his own company, that's Atkins in UK, Mr. David Bishop, who was personally involved in the replacement of hangers of the suspension bridge. Now, we all know that any cable supported bridge is said to be fragile. It needs to be made more longer lasting, durable by several means. Any cables that we provide must be replaceable, whether it's a cable stayed bridge or it's a extra dose bridge. I will not say to that extent, only the extra dose cables can be replaced, or if it's a suspension bridge, which is very important. If we talk of, for example, the largest suspension bridge in the world, that's Akashi Kaiko Bridge, there they have also used dehumidified air into the cables for its life. It's over the sea. And this Humber Bridge was constructed, I'm not sure whether 50 years earlier or 100 years earlier, but it's a 1.5 kilometer main span bridge. I think 1.4 over kilometers is the main span, means no supports. So in that bridge, and I don't know whether it was originally planned for replacement of cables or not, but in that bridge to replace the suspension cables is a job by itself. It requires a lot of dynamics and other things to be studied. And after that also to make the bridge still sort of vibration controlled 1.5 kilometer long span bridge is what has to be ensured and has been ensured by Engineer David. So with these words, and I, of course, my thanks from the bottom of my hearts to Engineer David that he has agreed to spare all his time, all his wisdom, all his knowledge, and he would be sharing whatever he came across. So I'm so grateful to him. And Mr. David, only one bit of a thing that I don't like is that I'll have to quit this lecture of yours at 5:45 because National Highways Authority of India, NHAI, has fixed up a meeting at 5:45 for a structure which actually collapsed, and I'm a part of the special investigation team of that bridge or flyover in Gurgaon, that's North India. So please excuse me for that. I apologize, but I wish you all the best and wish all the audience all the best, and please have a as interactive a session as you can make it. Thank you so much. And here to Mr. David.
Thank you very much, Vinny, and thank you everyone for having me. It's a great pleasure to be here and present to everyone today. I am having some IT issues and I remain having some IT issues. So I can't present the screen. I have logged in twice, once on my computer and once through my iPad. If I'm able to be promoted through my computer, I will be able to share my presentation. So if someone's able to do that while I continue my presentation, then I'll be able to share my slides with the team.
David, as I understand, you are not able to share your presentation, right? I mean, you're not able to present the screen, is it?
I'm not able to present my screen at the moment.
So is it possible for you to send an email to me? She will present it then. She will share it. If you
I can share if you promote me. I've signed in twice. I've signed in twice. So if you promote me for my other sign in, I'll be able to share my screen.
David, what he's saying is, if you send the presentation on email to us, then we can share it on the screen and you can ask us to move forward and all that.
Okay, I'll do it that way then.
You think that will be better?
Apologies for this.
But otherwise, the method is that you have to first open your screen, which you want to share, and then go at the bottom of Zoom and press share screen and double click on that particular small screen that you will see, which is the screen to be shared. So first you put that on the screen, whatever has to be shared, and then come to Zoom.
The problem is you haven't, I'm now signed in twice. Yeah. And so if you promoted me for my sign in with my computer, then I'll be able to share.
Okay.
Anyway, so I'll just forward an email to you, Vinny.
You think it will be a good idea for you to email the presentation to Mr. Swapnil Joshi and he can share on the screen?
Okay, yeah, let's do that. What's his email address?
Swapnil, can you read out your email while he's sending the email to you?
Yeah, it is Swapnil, SWA.
Yep.
PNIL, P for Peter, N for Netherlands, I for India, L for London, Swapnil. SWA, PNIL.
Yep.
At Intento, at INTENTO.
Yep.
Associates, associates.com.
Associates plural?
Intento associates.
Intento?
Associates, S.
Plural. Intento associates.
I just put you in chat also.
You have sent it on chat?
Yeah, I'm just sending it on chat.
Yeah, better.
That'd be good.
Because video is absolutely essential. Then only it's it has that weightage.
I'll send you an email address.
On the chat.
Send me an email.
Yeah.
Thank you.
So delegates, please wait because such things happen at time. And In the meantime, I request you please have a cup of tea or coffee, whatever you're used to.
No, so, I wasn't sure why I wasn't able to dial in straight away. It's been quite frustrating for me to dial into this presentation, but hopefully this will be a workaround where we can.
I think when you deliver the next
continue.
lecture, you will know how to do this.
I believe it's my IT system from work. What they do is they restrict some programs, and it won't allow me to install Zoom. So that's why I've had to dial in via my personal iPad rather than my work laptop, which is the issue.
So never mind. Have you been able to send it?
Yes.
I've sent it.
Swapnil, have you got it?
Yeah, I'm just downloading it.
Okay, very good. So David, you can keep telling Swapnil to go to next slide and next slide whenever you want.
Okay, will do.
Before Swapnil get download this, David, can I ask few questions, if you permit?
Of course, yeah. Yep.
Basically, how you are so passionate about the cables and all?
I think it's come from early on in my career. When I was a graduate, I worked on the Humber Bridge, which is a suspension bridge near where I work. And around that time, we were finding a lot of issues with the main cable and a lot of corrosion issues. And because of that reason, they were talking about building a brand new bridge. And this bridge has been iconic in my life. And it's a bridge that I've travelled over daily. And so for that to happen was a bit of a, it was a bit of a wake-up call that how important and critical these main components are for the structure. So from that day that I worked for about 6 years on the Humber Bridge, and then throughout that time working with the cables, and that's given me a good base knowledge for working with suspension bridges. Since then, I've worked on the M48-7 suspension bridge, which is very similar to the Humber suspension bridge, which I'm about to talk about. And then since 2017, I've worked on the Humber Bridge, as well as various other projects. But I think, I've been lucky in the fact that I've been working with quite large structures throughout my career.
So David, once along with Chris, one Monica Sandberg had come to India, and they both delivered lectures on Eurocode 2. So is Monica still there with Atkins?
It's Jessica Sandberg, yeah? Or Monica?
Mm-hmm. Monica.
Yeah,
Monica.
I don't know Monica, no.
Okay.
I know Jessica
Monica
Sandberg.
Sandberg, yeah.
Yeah, okay.
She had come to India and she was there for 3 days along with Chris.
Swapnil, is it downloaded?
Yeah, I'm just downloading it. It is
Okay.
28 MB, so it is 50% done. I'm just reading for it.
Yeah. Any
Gopal bhai, शायरी वायरी सुना दो in the meantime.
सर शायरी तो बनानी पड़ती है, सर शायरी बना देते डेविड जी, बनानी पड़ेगी सर, वोट ऑफ थैंक्स में. डेविड जी, something like, have you been to India sometime?
I've never been to India, no. No. But I've worked quite a lot with our India colleagues that work in Bangalore, and quite a few of my colleagues come from Bangalore but now work in Edinburgh. A particular friend of mine, Jane Verma. But personally, I've never been over to India, but would like the opportunity, to be honest.
You have a large office in Bangalore. I've been to your office in Bangalore. I think it's about 1,000 people.
Yeah, it's a big office.
Yep. Swapnil, what progress?
Swapnil?
Yeah, done. I'm just presenting it.
Very good.
So, is it visible for everyone?
Yes,
Yeah,
yes.
it is visible.
Perfectly fine.
Yeah.
Excellent.
Yeah.
Thank you very much.
Is it possible to get a control to David? I think in Zoom that option is available or not. Otherwise, okay, let's proceed.
I think let's start off is better.
Yeah, I'll just ask you to go to the next slide.
Let David ask.
Yeah.
Next time we can try the other thing also, as you said.
Yeah.
Taking control of the screen.
Right.
So today's lecture, I'm just going to talk primarily around the Humber Bridge and about the hangars and about a scheme that I've been working on since 2017 to replace the hangars. If we go on to the next slide, please, you can see the sort of agenda for the meeting. First, I'm going to talk about an introduction, then I'm talking about facts and figures of the structure, the background and really the reason for carrying out this testing, and there's been very detailed testing being carried out of the hangars. Then the analysis and the testing specification that we put together for the bridge, the test conclusions, and the results of that testing will then be presented. So we go on to the next slide.
Yeah. And David, can I request you for just if you can just increase your volume a bit, it will be more audible.
Increase my volume.
Yeah, I mean, it's a little bit less audible, so you can just.
Can you hear me okay?
Yeah, now it's fine.
Yes, yes. We can speak closer to the microphone. That would be fine, I think. It's much better now.
Okay, so the Humber Bridge, it's located on the river or the Humber estuary near Hull. You can see the picture there. And there's up to a 64-mile diversion in the event that the bridge is closed. And because of that reason, all the work that we do on the Humber Bridge, it's really required that we don't close the bridge entirely throughout the duration of the maintenance. Also, if the bridge was to close for any full hanger replacement schemes, that will be a significant impact, both cost and economy, to the local economy of Hull. So for that reason, we try and do all works with the bridge open. We go on to the next slide, tell you a little bit about the Humber Bridge itself. It was opened in 1981. When it was opened, it was one of the longest bridges, or longest main spans in the world. At the moment, we believe it's still around the 11th longest bridge in the world. It's certainly a major feat of engineering. It is the longest suspension bridge in the UK, and it's still the longest in the world to walk a cycle across the world. It was the first suspension bridge to use reinforced concrete for the towers. Previously they were all steel. The next slide shows the overview of the bridge, 2,220 meters long, the main span being 1410, with two back spans of 530 meters and 280 meters. Now, what we're going to talk about, or I'm going to talk a lot about today, is the inclination of the hangars. Now, the hangars are the cables that connect between the main cable and the orthotropic steel deck. These hangars are inclined, and it's a very unusual feature of the bridges that were designed by Freeman Fox and partners around this time. And the inclination of the hangar actually causes quite a lot of structural behavior changes of the bridge, and also quite a lot of maintenance issues that we're going to talk about in a lot more detail. Now, the width of the bridge is 28 meters wide. You can see the orthotropic nature of the bridge there, that it's to limit the amount of wind loading on the side of the bridge. So on to the next slide, we can see, I believe, 3 different bridges that were constructed by Freeman Fox and partner. Now, the Severn Bridge was constructed in 1966. It was the first bridge. This bridge had significant issues due to the inclination of the hangars. The hangars had first reported wire failures of the individual wires after 8 years in service. After 22 years life, all the hangars of the Severn Bridge was replaced. And the reason for this replacement was partially manufacturing errors in terms of the alignment of the hanger and the socket, but also because the way the bridge is comprised of triangulation of the hangars, there was a significant difference in hanger loads between the hangars that are inclined towards the tower opposed to the hangars that are inclined towards the centre of the bridge. And I'll talk at length about that later on. The Bosphorus Bridge in 1973, the hangars were replaced on that in 2016. Interestingly, the hangars for that bridge were replaced with vertical stay hangars. So we were approached by Humber Bridge Board in 2017 and asked, well, our hangars have been in service for 38, 39 years. Should we be replacing our hangars? And if we do need to replace them, how do we replace the hangars? So if we go on to the next slide, this talks in detail around the Severn Bridge and the issues that I just highlighted. So 22 years when the hangars were replaced, the fatigue life was adversely affected by the difference in the permanent loads in the hangars that were caused to go slack. If you go on to the next slide, this shows the Bosphorus Bridge, and it shows how the hangars were replaced. The hangars being replaced with vertical members rather than inclined hangars to take away the issues of the inclination. The next slide will show you the Humber Bridge hangars and the connection to the deck section. Now the Humber Bridge has 484 hangars. The hangar life is approximately 25 years, or was designed to be approximately 29 years. So having currently got 38 years in service, the hangars are old and they're due for replacement. However, what we quickly determined when we went to site is that they were in good condition. Visual inspections throughout its life had kept the hangars in reasonably good condition without much sign of corrosion. Now on the right hand side there, you can see a little bit of a makeup of the hangars. It shows that the hanger cable, the lower socket, which allows in the worst locations, it allows sway movement of the bridge, also longitudinal movement of the bridge, which helps to reduce the bending forces within the cables. The articulation link between the main cable and the deck stool also allows a minor adjustment of 8 mil plus or minus to change the load in the hangars. And that was used for during construction. So we go on to the next slide. So what we're looking at, is it feasible to replace all the hangars in situ without closing the road? Or is it feasible to carry out hanger testing of these hangars to see if we can keep the hangars in physical condition? Now, we decided there was a significant cost benefit if we carried out extensive testing of these hangars to prove that they had significant design life left. Now, physical testing meant that we had to do fatigue and ultimate tensile testing in the zones of the highest stress. So part of our exercise was to determine which hangars were the most critical and highly loaded, and also to avoid structural health. It should be noted that this building is a listed building consent, so rules in England are such that
Mr. David, may I interrupt you?
Yes, yeah.
People are saying that the volume still is not adequate for them to easily understand. You know that there's a volume control on the right side of the mute button, where you see a mic type of a thing. On the right side, there's an arrow. You know how to adjust the volume, input volume? At the bottom, you see a mic, which at the bottom of it, mute is written. On the right side of that, there's an arrow. If you press arrow, there will be an option of audio settings, the last option.
Is that any better? I can just hold my iPad closer if that works.
So on the audio setting, if you are able to go, then you will see input volume, and that can be maximized.
There is nothing that's not available on my screen.
No, okay. Okay, then let's see if we can be louder by some means, or a microphone brought closer to your mouth.
Is that any better? Can you hear me now?
Not much. Okay, whatever best you think. If you are not seeing this control, normally we have this control at the bottom of the screen.
It's because I'm using the iPad. It doesn't.
Much better now.
It's better now, yeah?
Yes, yeah. Please go ahead.
Okay, so we go on. So as I was saying, the list of building consent prevents prevents any modifications to the aesthetical appearance of the Humber Bridge. And for that reason, any modifications we made had to be like for like. If we go on to the next slide. So we put together a team, and the project team put together by Humber Bridge Board was Atkins as the designer and the structural checker of the bridge. Spencer Bridge Engineering is the contractor who's going to carry out the construction works. Cowie was supporting them in some temporary works designs of access platforms. Bryden Beckett Group, they are the fabricator of the new hangars that were going to be in place for the bridge. DNVGL are the team that are carry out the extensive testing. So we look on to the next slide. So our structural analysis of the bridge found that the hangars immediately off center of the center of the bridge had the highest both dead load and highest load in service. This was critical because it had the highest fatigue range. If we go on to the next slide, this shows the hangars that are the visual survey that was carried out to look at the condition. Now, what we found is using a combination of the worst fatigue loading on the hangars together with the condition, we're able to identify the worst hangars on the bridge for a subjective test. Now you can see the one in red there is hangar 1617, and it was one of the ones selected for replacement and testing, along with two other hangars. So at the end, we selected 3 hangars from the west side of the bridge. If we look onto the next slide, this details the 3 hangars. Now, what we wanted to do is select hangars that were going to adequately represent all the different conditions of the hangars, but also that were possible to replace in an easy manner without damaging the hangars. And so these hangars ranged from 9 meters down to 4 meters in length were considered the best hangars. If we look on to the next slide, this gives you some of the details around the temporary hangar arrangement. Now, there was various options chosen, but what was critical for the design of the temporary hangars is that the hangar creep and elongation over its in-service life didn't cause a significant change in the load pattern of the bridge. So if we installed a hangar that hadn't been correctly shaken out with correct frequency analysis, frequency loading of the new cable, then that would cause a distribution of loading throughout the adjacent hangars. And so to avoid that, the best hangars that we could find were fully locked coil hangars that were adequately loaded. And for that reason, we were replacing the existing spiral strand hangars with a fully locked coil hanger. If you go on to the next slide. This is a picture showing the construction of the bridge. Now, one thing that was critical in terms of the construction was what was the dead load left in the hangars after construction. Now, when it was constructed in 1981, there wasn't so sophisticated non-linear structural analysis packages that we have today. And so they weren't able to accurately model the triangulation effects of the hangars. So the hangars were assumed or designed to be in equal loading between the triangulations. And to accommodate that, there was a small cam at the bottom of the hangars that allowed the adjustment of the length to ensure the hangars were the correct length. However, our analysis, if you move on to the next slide, you play this graphic, it shows the construction sequence as constructed throughout the bridge. And at the very end of the graphic, what we found was there was a higher stress in the hangars facing the cables. Now, this was impossible to remove by the small cam at the bottom of the bridge. So we suspected that, or we found through our analysis, that the hangars were significantly unevenly loaded. And that wasn't something that the original designers were aware of. So we look on to the next slide. This compares the load from Freeman Fox and Partners. Each hanger that they assumed was 410 kilonewtons. The actual the nominal jacking loads that we determined through analysis was 793 for the first one, and the actual jacking load was 950. And comparing that to the hanger 1617, the nominal jacking load that we derived was 137 versus 290. Now, the reason why the actual jacking load is slightly higher is because you have to overjack the deck to allow the pins to be released. So what we found is that the nominal load in the hangers were aligning with our analysis rather than the original design of the bridge, whereby the hangers should have been equally loaded. So if we look on to the next slide. This is another part of how we did the assessment. We use weigh in motion data, which is which as vehicles pass, it weighs the vehicle, counts the number of axles and the size of axle loadings. From there, we use statistical distributions to calculate the theoretical worst convoy of vehicles, and we use that as the bridge-specific assessment live loading, and that's used as the worst case assessment. If we use normal standard codes for loading, then the bridge would be assumed to be overstressed because loaded lengths of this length have a significantly lower probability of having high intensities of loading. This is taken into account by the bridge-specific assessment live loading. Now, what this graph shows is that the 45% of ultimate tensile strength is around 1305, and all the hangers are below that strength. So we had good information that the hangers probably aren't suffering from fatigue damage if they were in good condition. However, the hangers aren't in good condition. They've been there for 38 years. They've been damaged through corrosion. They've been damaged through wires coming out of blade, etc. For that reason, we needed to carry out some further testing. So if we look on to the next slide. This was in situ strain monitoring that we carried out for the bridge. This is using a digital image correlation system where we use very high resolution images of the fracture surface to determine strains in real life. And this was correlated against our model and found to show good agreement, which enables us to understand the loading throughout the cable. We go to the next slide, which shows the DIC monitoring used not only for the micro strains of the cables on the hangers, but also for the overall movement of the bridge deck, which we found that was also in agreement. Go on to the next slide, please. As well as that, we use known vehicle loads to measure the displacement of the vehicle. You can see there three known vehicles of 11 ton each, and the analysis carried out to measure the displacement, which is shown in the top left-hand graph. If we go on to the next slide, please. So to replace these three hangers, we needed a temporary works design that could safely remove the hangers whilst the bridge was open to traffic. Now, part of the detailed analysis work that we've been carried out to date is, can we remove the hangers without closing the bridge and also without putting in temporary works to support the decks? Now, because of the loading distribution of the hangers, it was very critical that during the replacement there wasn't full live loading on the deck, and so for that reason there was a partial closure down to 2 lanes. And Cowie with Spencer's designed an access platform that could allow the temporary removal and jacking of the bridge to remove the hangers, as you can see in these pictures. On the next slide, you can go to the next slide, please. Yeah, thank you very much. This shows the actual removal. The hanger is essentially jacked down towards the bridge, which increases the load in it. The pin is then removed and then the bridge is slowly lowered to remove the load from the hangars, and that allows gradual replacement of the hangar. It was carried out in one night. One hangar was removed and replaced each night. So over the works, there was 3 hangar replacements. You go on to the next slide, please. So these were the choice in hangars. So hangar 10-9, it had the highest fatigue load range amongst the central span hangars, and it was the greatest maximum load under permanent and fatigue loading. It was 4.3 meters long. There was no visible signs of corrosion, but it appears to have wires out of lay, indicative of possible wire fractures, which was a particular concern that we wanted to assess during the assessment. The hangar tested for its residual fatigue life and ultimate tensile strength. Hangar 16-17, its hangars with the lowest permanent load. As I've shown earlier, there was significant variation in load, and if the entire bridge was loaded, then it was subjected to theoretical decompression under live loading. It was 7.7 meters long. It was in the worst physical condition, whereby it had corrosion of wires and wires out of lay. It also had water seepage from the hangars. This was proposed to test this hangar to destruction. Hangar 18-17 was 9.2 meters long. It had the greatest fatigue load, and again, it was proposed to test this to fatigue loading and ultimate tensile strength. If you go on to the next slide, please. This just really shows an overview of the previous what testing was to be completed: visual examination, fatigue testing, ultimate tensile strength, fracture surface examination, chemical analysis. Now, we did look at exploring the possibility of doing individual wire ultimate tensile strength to see if, similar to the NHCHRP 5.3 report, we could rederive the hangar strengths from visual observations. However, it was decided after testing that wasn't necessary, so it was taken out of the scope. Again, fracture toughness, we hypothesized that perhaps fracture of the wires were controlling the failure mechanism, and for that reason, we would look at doing some fracture toughness evaluation. Again, that wasn't required after the initial test was carried out. All hangars were tested by DNVGL from Norway. We'll look on to the next slide. So the hangar testing acceptance criteria for the fatigue: if the hangars were able to survive 2 million cycles without detected breakage more than 2% of the wires, then it was deemed successful. As long as there was no failure in the anchorage material or any components of the anchorage during the fatigue test, I would consider the fatigue test to be passed. Tensile test, it must reach at least a force of 95% of the minimum ultimate tensile strength test, defined from the characteristic strength of the strand. Also, the strain under the maximum load should not be less than 1.5%, allowing for deformation inherent in the operation of the anchorages. So we move on to the next slide. This shows the full-scale testing equipment that was carried out. This is for hangar 16-17. It's been set up for the ultimate tensile strength test, which is the first test that we carried out. You can see there the condition of the wires. The hangars, although in pretty good condition, you can see a few wires out of lay and potentially painted over throughout its design life. So this is one of the worst condition hangars. If we go on to the next slide, we can see some of the test results. So for this first hangar, it achieved a nominal braking load of 3,016. This was less than the original 3,216 nominal braking load, but greater than 2,900, the minimum braking load specified. So essentially it passed the test. The breakage, interestingly, was towards the top, the upper socket, where we suspect the bending stresses will be higher due to the bridge sway. And at the top of the hangers, there was only one articulation arrangement, so it had higher bending stresses opposed to the bottom socket. Again, the breakage results there to the left had a 3.4% straight average strain, and therefore it passed the results. If we look to the next slide, this is a video showing the actual breakage. Maybe if you can play it again, what you can hear immediately before breakage is some of the individual wires breaking before the entire cable fails. So we look at the next slide. As part of the Severn Bridge, one of the things that contributed to the failure of those hangers was misalignment of the socket with the cable, as well as voids within the anchors causing significant corrosion. And for that reason, it was the hanger socket was taken apart after the destructive testing. It was dissected and inspected. The results of that were very good. There was no visible corrosion. The condition of the individual wire strands were good. There were some small minor air pockets within the zinc metal, but overall it was very good condition. Go to the next slide. This is moving on to the next hanger being tested. This one is hanger 1718. It was proposed to, this one had an average metal coat paint of 600 microns, so a very thick paint. The cable also had an internal lubrication and fluid within inside, which had leaked out over some of the duration of its life. And you could find that more of the lubrication fluid at the bottom of the cable were less at the top. I think that was also causing further corrosion at the top of the hanger as opposed to the bottom. So we look to the next slide. So this was the fatigue testing carried out. The upper bound load was 883 kilonewtons with a lower bound of 705, 178 kilonewtons difference. The fatigue cycles were over 2 million fatigue cycles. Now the stress range on 1718 was based on the FLM3, which is one of the Eurocode loading parameters, and that's a fatigue loading vehicle crossed over the bridge. It had the highest predicted fatigue stress of 78 megapascals over 2 million cycles. Now, the British standards or the Eurocodes 1993 Part 1, Part 11, if you were designing a new bridge today, you would test for a fatigue cycle of 150 megapascals. However, we didn't want to test for a very high stress range initially because there was concerns that the hanger would have very limited fatigue resistance and therefore would fail. So because of that reason, we first tested to the known fatigue load of 78 megapascals. We look to the next slide. This shows the test setup. So because of the possible misalignment between the cable and the sockets, this was included within the test by causing a misalignment of the socket by 0.6 degrees, as can be seen to the left-hand side of this. And this is also recommended by BSEN 1993 Part 1 when carrying out the construction of new bridges. We'll look to the next slide. This is a picture of the hanger, the fatigue testing being carried out. And the bar to the left-hand side there is actually how they induce the rotation of the socket to cause that misalignment. Now the test was then set to a nominal 58 kilonewtons, 2% of millibraking, to allow for final inspections and measurements prior to the testing starting. Acoustic monitoring was set up to install to listen for wire breaks throughout the fatigue testing. Now, the fatigue testing was carried out at 0.67 hertz, and that took 35 days for each hanger. So for the two hangers carried out, there was this was in the machine for over 70 days, or the two hangers were in the machine for over 70 days as the fatigue cycles were being loaded. If you look to the next slide, please. So the test was completed to 2 million cycles. There was possibly one wire break between 88,000 kilonewtons because of the sudden increase in the peak through elongation. So you can see that on the graph there with that increase in elongation of the yellow line and the grey line. And that's indicative of fatigue failure carried out during the testing. However, throughout the rest of the test, there was a very steady displacement, proving that there was no other damage during the testing. Look on to the next slide, please. This hanger, after it carried out the 2 million test cycles, it was taken to be carried out for the ultimate tensile strength test. It was possible that during the fatigue testing, significant damage would have occurred to the hanger, and then when the ultimate tensile strength test occurred, we might get a significant reduction in the breakage. But what we found was that the actual breakage load was very similar to the previous at 3070, again greater than the minimum breaking. So it was a positive result to prove that the hanger hadn't damaged during the fatigue testing. Look to the next slide, please. Yep, this just goes through where the wire broke. It was towards the top socket where there was less lubrication because of the inclination of the hanger. There was also some more corrosion damage. On dismounting of the wires, found that on layer 3, there was one potential wire break detected in the fatigue testing. The mode of failure for each individual wire was a ductile failure. And we didn't see, in this instance, a brittle failure of the wires. So we go on to the next hanger. This picture shows you the different failures as you move away from the main breakage. At 3.4 meters, you can see wires that have broken and come out of lay. 3.6, again, the wires have significantly deformed, showing the location. If we go on to the next slide. This is moving on to the last hanger. This hanger was carried out to a much higher fatigue range with an upper bound of 1,118 kilonewtons and a lower bound of 849 kilonewtons. That's a difference of 269 and 119 MPa. If we look onto the next slide, this shows the test setup. In this instance, we assumed that one of the bottom hangers sockets had seized in rotation, which would cause additional bending stresses to the hangers. So for that reason, we tested the 2 million cycles with two bends, one at the bottom and one at the top. Rather than testing at a similar stress range as the previous hanger, we've tested at an increased stress range, as I've said, of 119 newtons per millimeters. Can you go to the next slide, please? So one of the things that happened during this testing is we'd specified the testing to be carried out in 2019. Now, during the actual testing of the first hanger, there was some research being carried out by the group that looks after the Eurocodes, working group number 11. And this found that for the lambda factor is the factors used to calculate the damage equivalent stress, to have no obtainable background. And because of that, there were concerns raised of the use of FLM3 during the assessment. If you look to the next, the concerns that they found was that mostly the FLM3 was conservative, but In certain instances where there was long influence lines, particularly for two-span bridges, the gamma factor wasn't conservative. In our instance, the Humber Bridge had a very long influence line because it's a cable supported structure, and so we had concerns that the initial test that we did, the lambda factor wasn't appropriate. If you look to the next slide. Now, in February, before February 2020, the original SN curve is shown here at 150 megapascals, and we carried out a test at 78. We look to the next slide. This shows the new curve proposed to be carried out to 145, but then critically at 115 megapascals, they proposed to have 5 million stress cycles. And if you look to the next slide. So for the second cable, we proposed to carry out our testing to 119, which was an alternative proposal for the 1993 SN curve. Okay, let's the next slide, please. This is just looking at the fatigue results for Hangar 910, which has had was under higher load. Again, there was no evident damage at the end of the fatigue testing. If you look on the next slide. Damage during the testing, you can see there around the 800,000 cycles, there was a significant jump in load, and we think that was due to 2 wire breakages caused by the fatigue loading. Although no wires could be seen broken on the outer surface, and therefore these wires were broken on the inner surface. If you look at the next slide, please. Tensile strength results after the fatigue testings, again, very similar results, 3025 with a 2.9% average strain. The failure was at the top end of the hangars, and you can see the breakage close to the hanger, this close to the socket. Okay, next slide, please. So because we had concerns over the FLM3 modeling we've done, and particularly around the lambda factor we used, we did a further analysis of the bridge for fatigue load model 4. That is a much more complicated fatigue model than fatigue load model 3. It includes over 23 different vehicle designations, and it runs the different vehicles in different convoys across the bridge. Now, although it's quite analytically heavy, what that proved was that although the lambda factor was quite inaccurate for long span bridges, it proved that the stress range throughout the hangars was within what we previously specified. And what you can see here is on this graph is the difference between the dots is the fatigue range that we determined. You look to the next slide, please. This just shows the procedure for counting the different vehicles and counting the number of stress cycles used in the fatigue load model 4. What's interesting to note on the left-hand side there is the influence line is very long. You can see it there, nearly the entire length of the main span, and that's due to the fact that the inclination of the hangars causes a change in load of the hangar, regardless of position on the bridge, because it changes the permanent load distribution within the structure. Okay, next slide, please. On the final hangar, we found one of the surfaces had a ductile failure. After doing fracture surface examination, we found some corrosion pitting to the top of the wire. There was a probable, although we can't confirm this, but there's a probable fatigue propagation throughout the fatigue cycles, and then the hanger or the wire failed in breakage due to stress concentrations and the lower proportion of that slide. If you look to the next slide. As well as doing factual examinations, we categorized each wire based on the NCHRP 534 method that looks at the amount of oxidation as well as rusting on the cables of the different layers. What was interesting was on the outer layer, the corrosion category was stage 2, and on the second layer, there was some wires that were found to be in stage 4. So the reason for this being is that the outer wires were protected by the metal coat. However, on the internal wires where the lubricant had leaked and water had managed to get into some of the cables, there was additional sort of corrosion on the inner wires. In general, however, we found that the majority of wires were in reasonably good or very good condition given their age and how much in-service use they had. And it hadn't caused a detrimental reduction in either ductility or strength of the individual wires. Look to the next slide, please. If you can go to the next slide, please. Okay, so overall conclusions then. There's a residual fatigue life confirmed based on the FLM4. The fatigue testing proved that the hangers had significant further life. Failure after fatigue remains ductile, so warning is expected, and current factor of safety is over 2. The corrosion protection system is key to good service life. Replacement likely to be able to be deferred as current condition indicates 120 years more life without environmental deteriorations. And what we're doing is we would quite like to share these results with other long span bridge owners so that it really promote low intervention structural refurbishment. In this instance, we could have went down the line of replacing all the hangers. We've certainly developed a methodology to do that. However, this, although expensive, this testing has confirmed that there's significant residual life in the hangers, and deferring the replacement by 10, 15, 20 years, depending on the effectiveness of the corrosion protection system, will have a significant whole life cost benefit to the bridge at the moment. We look at the last slide, I think. So acknowledgements, the project wouldn't have been possible without everyone else, part of the team, Suspensors, the contractor Cowie, Brydens and DNVL, also the client Humber Bridge Board have all played a key role in making sure that this project is a success. The client is in the process of looking to extend the life of the hangars and carry out more corrosion protection measures to continue the life of the hangars, which saves both taxpayers' money and the environment with a minimal intervention approach. If you've got any questions, then I'll be happy to help. And I would like to apologise a lot for the IT issues that I had at the start of the presentation. Having to work from an iPad isn't ideal.
So David, there are certain slides after this also. Okay, so this is the last one, right? I mean,
that's the last. Yeah. That's the last one. Yeah, I put some extra slides in there around digital image correlation in case anyone had any questions around how digital image correlation works. However, that is the end of the presentation on the Humber.
Yeah, great. So,
shall I take over, Swapnil?
Yeah. Yes. So you can just.
Thank you, David, for such an excellent presentation. And really, it is one of the great project because the data you have captured through this project is quite rare for the bridge community, and that will change probably the number of codes. Before I start getting a questions from the participant, I have a few questions to you. First is basically You have checked using the FLM3 as well as the FLM5 or FLM4 models, fatigue loads of this Eurocode. Okay. Hello, Mr. David?
Yes, yeah.
Yeah.
Yep.
But since since the bridge is in operation, you could have obviously taken a reading from the actual traffic running on the bridge, and with the statistical processing, you could have used the FLM model 5, which is the actual model, and you could have may have got some different results.
Yeah, we did consider that. We had weigh in motion data from 2013. After that, the weigh in motion data stopped working, and the client hadn't replaced it. The way we found that the traffic had increased since 2013, and so we did use that data, but we only used it to calibrate the FLM4. We didn't have, although we had specific vehicles and axle weights, what we didn't have is a point in time, and so what we couldn't do is create or use statistical distribution to work out what vehicles were passing in what spacing. And because of that, the size of the convoy was really key in working out the critical loading. So we could have made some alternative assumptions, but because we didn't have the full data, FLM4 was deemed to be as accurate or as accurate as we can make it.
Because the FLM4 is basically validated on a French highway, what I understand.
I think it was the British nationalics for FLM4 is different than the Eurocodes, and the British nationalics details 23 different vehicles from British roads, and gives rules around the fatigue loading to be used. Now we found that the FLM4 and the nationalics wasn't that clear, and we ended up using the information from the weigh in motion to basically correlate how many vehicles should be used in the convoy.
And this lambda 1 factor, again, it is very tricky to use that factor for a suspension bridge, because the code, that is a 1993 part 2, that says that it is validated up to 80 meter and not more than 80 meter length of the critical length of the influence line. So what exactly you have done for such a large span? How you have basically manipulated this lambda 1 factor?
Yeah, it was difficult to do, and there's clauses around arch bridges that show the lambda 1 value for individual hangars, which assumes that most of the load or most of the critical fatigue loading is between the hangars. Now, obviously, on the Humber Bridge, we found that wasn't the case, and there was a lot longer influence line, and that is why we had concerns of whether it was going to be valid. We did find that the FLM3 was conservative after doing the FLM4, and the lambda value we used was, I think lambda value was about 1.7, so it was quite a value.
At the end, you said that you are changing this SN curve of 19931 part 11. You have told some different SN curves. So is there a proposal to change the SN curves given in the Eurocode for this tensile members, tensile elements?
So that's been changed already. It was changed in 2020, February, earlier this year.
Okay.
The reason for that change was because over the length of the structure, they had greater concerns. What we did is we derived a new SN curve based on our two test points, and from that we found that all the hangars theoretically were below that SN curve.
One general question: see, this bridge was designed about 40 or 50 years back, and that time you must have, or that designer must have used the BS codes. Now, with this new Euro codes, do you have to again qualify the entire design of the bridge, or it was not, you do not find that is essential?
We didn't have to verify all of the bridge, but we had to verify everything that had substantial load change. So particularly when we were removing the hanger, in that temporary load condition, there was increasing stresses in the stools, increasing stresses in the hangers, in the orthotropic deck. All those things we had to verify and confirm.
So basically you have to use that 1.5 factor with the hanger removed minus the with hanger, and for that condition we have to again qualify the bridge for that transient condition.
Yes, that's right. Yeah. And to get that to pass, we needed to have a traffic management system in place down to one lane in the direction.
Okay. And one again question: when you removed that hanger, you might have used for a temporary time. Was there any temporary hanger was introduced to when the traffic was again allowed to fly over the bridge, or it was installed the permanent hanger itself?
We just removed the hanger and lowered the deck down. So for the temporary condition, there was no temporary hanger in. So that's why there was an increase in load in the adjacent hangers.
Now you have tested the hangers. What about the main cable, the suspension cable?
Yeah, so that wasn't part of this remit, but yes, every 7 years they go in, and we've done it on the M48, the 7 bridge. And what they do is they open up the cable in accordance with the HRP method. They drive in large wedges essentially, and inspect all the individual wires, and extract wires for individual wires for testing, because these parallel wires. And that was done in conjunction with our works or before our works, and because of that, they've installed dehumidification systems to drive the cables to make sure that there's no future corrosion. There's also acoustic emission monitoring of the main cables. Listen for wire breaks. That was one of the things we considered. Is it possible to use dehumidification systems for small cables? And it was just, it was proved too impractical given the number of cables and the length of them to use a system. Although it's very practical on the main cable.
Another observation is you have tested 3 cables. 2 are for the fatigue and 1 is for the ultimate load testing. Even after testing for a fatigue of a 2 million cycle, your ultimate load was the same for all the 3, almost same. There was not much difference. So that means this cyclic loading on any tensile element does not affect the ultimate tensile stress of the steel.
Yep, that's what we found. Yeah, there wasn't sufficient damage of the cables from the fatigue to cause a significant change in the ultimate load, and that's what that's for a new cable in the theoretical brand new condition. We thought that's what we'd find. However, because we didn't know the internal condition, we didn't know the corrosion pitting. What we hypothesized we would find is there would be more breaks during the fatigue loading. Small pitting causes stress concentrations. Then during the fatigue loading, you might get a lot more cables breaking. However, the cables found in good condition, that we just didn't find that. They were in good condition.
Great. So I will open the platform for the audience. So please, if you have any question, please put it in the question and answer this one. Let me just see whether there are any questions. There is how much time? Yeah, can you take it, Swapnil?
Yeah. So it is there's a question from Vinod Kumar Sengal. He is asking how much time it is taken for replacement, and whether any traffic was suspended during the construction.
There was a number of night shifts initially so we closed one lane of the bridge, a number of 2 night shifts to lift up the temporary platforms and then make safe. Then during a nighttime lane closure, the hanger was removed. As I've said, there was no temporary hangers, so the hanger was detentioned and a new hangar was put in over one night shift, and the traffic cleared. And so that was done 3 times, so on 3 different occurrences.
Great. Okay. Right. So before going to the other question, let me just ask our senior members in the panel to get their views. Mr. Goel, Ravindra Goel, sir, if you can put up your views and any questions if you have.
Yeah. I have some practical questions. First of all, I just want to know, you did this project after a service life of 45 years or so, right? So
yeah,
the original design loads, there must be some design loads originally taken in the design. And when you did this project, during the actual observations, did you find some increase of loads over the design loads?
Actually, no. We had the original design loads, which again were not, because of the size of the structure, were unique for this structure. And we derived bridge-specific assessment live loads from the 2013 weigh in motion data, and we found that the loads stayed very similar. The reason for that is, although the traffic had increased a lot significantly since the construction was built, the number of HGVs had decreased. So the percentage of HGVs had gone down. The weight of the HGVs had gone up. However, because the number of HGVs were diluted by a lot more personal travel and personal vehicles, it was found that the overall B cell was around the same number, to be honest.
What was the original design life? And when you did this project, what is the residual fatigue life you feel is the bridge is having?
Yep, so the original design life was 120 years. Obviously, during the temporary works, we assumed a return period of about 120, no, of 1 in 20 years for the temporary works. The testing that we specified was designed to 120, the fatigue testing was 120 years design life. However, what we found from the testing is that corrosion is critical. So although if you can halt the corrosion of the cable as it is now, then it would last for more than 120 years. We don't think that's practically possible. You'll continue to get corrosion pitting and all these other things that cause stress concentrations, and that will then start causing you to have issues with fatigue in the future.
That's fine. I think it's a very good project in which you have tested the cables, hangers, and then you have found out that they are having still a factor of safety of 2, which I think you have said somewhere, and they have sufficient fatigue life so that the bridge can be continued for much more greater life. Is that okay?
Thank you. It's saved 18 million pounds in hanger replacement as well, so it's a significant win for the client, I think.
So now let me just ask Mr. Ashwin Subbarao if he's also there. If you have any, I think he's not there. Anything from Tambe, sir, SR Tambe?
Sorry, I joined late.
Yeah. So I thought you were on mute. So if you have any views on the presentation and any question, so please. You're on mute, sir. You're on mute.
David, I've been on that bridge many times. I even visited when it was being constructed.
Wow.
When it was being constructed quite a few times, studying at Imperial College in London, it was easy to do. And it's a beautiful piece of work. Wasn't it recently the width was extended? Was some lanes added to it at any point in time?
I don't think.
Not so.
No.
Okay, but the bridge is a beautiful bridge. I mean, it's absolutely fabulous. It hadn't been open to traffic when we visited 2-3 times. Once from the Institution of Structural Engineers and once with my uncle from Parsons Brinkerhoff. We came there as a special visit. Yeah. Wonderful. Thanks for the presentation. Hope to see more people from Atkins. Lots of friends in Atkins, Dr. Naval Shetty, and so many of my friends in Atkins. I hope to see them also join us in this fora and share knowledge.
Okay, I'll pass on the message. Yeah.
Thanks.
Thank you.
So, great. So there is one more question from S.R. Tambe, he's our senior IIB member. So I think I'll request him to unmute by the time I'll read his question. So what the question is basically, since the three hangars were tested to break, uh, presumable new hangars installed in their place, were they of exactly of the same properties as the old ones? So this is a question from Mr. Engineer S.R. Tambe.
Yep. No, they weren't exactly the same properties because it was very difficult to replicate in very small quantities spiral strand wires. We opted to use fully locked coil cables, which had been fully cyclically loaded to remove any pre-stretch and reduce the amount of creep that might be over the cables, which will distribute the forces. We had to match the properties as good as we could in terms of the E value in particular, in terms of the bending stresses. There was testing done of the replacement three hangars to ensure that there was as close a match as we could get.
Right. Okay. So, Tambe sir, if you can unmute yourself and if you want to ask anything or give your views, you're welcome. So I think I'll just ask you to unmute yourself. By the time if you do so, let me just.
Yes, I have unmuted.
Yeah. Yes, Tambe sir. Yeah, please.
My question is not related to the main subject. I am curious to know whether the hanger points where the suspenders attached to the main deck, they were also inspected any way to gauge their ability or remaining life.
So you're talking around the hanger stools that connect the cables to the main deck, and also the main cable strand bolt, or the main cable clamps that clamp onto the main cable. The stool at the bottom, because the way we were jacking, it caused additional stresses in the bottom stool weld, and because of that, we had to remove back the paint, carry out some additional welding at the bottom of the stool before we could install the temporary jacking arrangement that then put preload into the hangers, that enabled the pin to be removed, that then allowed the load to be slowly released. So on the bottom, we certainly did do an inspection and analysis of the stool. On the top, on the cable band bolt, it was just visually inspected and found to be in good condition. We couldn't see any cracks, and because the loading path wasn't changing in that member, it was deemed acceptable as it was.
Thank you.
That answers the
Yeah.
question. Thanks.
So David, one more question. Hello.
Yep.
Yes, go ahead.
Yeah. When you install this new hanger, how you manage to get the same stress level as the original hanger?
It was quite difficult because we had to specify a length of hanger that had to match exactly the hanger that came out. So what we did is there was a detailed survey carried out of the existing hanger that was correlated with the expected stress in the hanger. That was also correlated, to the strain testing that were done. Although the strain testing couldn't measure the in situ dead load, the only way to estimate the dead load was through the model. Then what we found is we went in and we jacked up the deck, and at that time we recorded the actual load in the hanger. We compared that to the fabricated hanger to make sure that the length was in tolerance. And it was. We did have, the fabricator had difficulties the first time that they fabricated the length, because they've got to take into account cone creep, etc., of the fabrication. And so once they had to measure the new hanger under load to make sure the correct length, and they found that the first one they measured wasn't quite right, so they had to remake one. But yeah, just because of the tolerance we were working to.
Good. Achha, this DIC, that is digital imaging cameras. So, and you are measuring a strain with those images. correct?
Yes.
So what is the resolution of these cameras?
I'm not the technical guy for that, but
Okay.
the guy that uses it, Jan Winkler, is one of our colleagues. He's been sort of pioneering this throughout the world. He's done it on quite a few large structures, including the Great Belt. The resolution is so fine that they can, and it uses sort of vibration software that they can pick up pinpoints on, and then measure the strains from any kind of relative movement. And it's really quite accurate and a lot more adaptable than trying to stick on conventional in wires. So it seems to be a good technology that
good technology. Without any intervention with the structure, is a really wonderful technology.
Yeah, I think steel, corroded steel, in fact, that's got sort of little pitting in it. That is actually the best for strain monitoring because that correlates well to the digital image. However, the software picks up the different points.
Great. So good. So any other questions are there, Swapnil?
So in the question, let me just check again. So there is a question. Is there any from Muhammad Ali? Is there any why only particular hangers got damaged? Is there any specific reason for that, or any conclusion for that? Why specific hangers are being damaged?
Why were they being tested, or why were they being damaged in situ?
I think it is in situ, I suppose.
Okay.
So yeah.
Yeah, I think there's a few reasons for damage in situ. One was just the breakdown of the corrosion protection system. The longer hangers have dampeners on them to reduce vibration. However, in all axes, the bridge sways and swings, and despite the articulation of the pins at the bottom, there are still small bending stresses which cause cracks within the coatings. That allows some water to get in. The internal lubricant of the hangers also sort of with gravity over time has leaked down and caused voids at the upper half of the cable. And so water has got in some locations to the top half. That's why we saw sort of a small reduction in some of the hanger loads, but not a significant reduction. I think over time it's imperative to try and inject at the top of the hangers, try and inject more lubricant to fill those voids if possible, but then also regularly reapply the corrosion protection system, which is a metal coat corrosion protection system.
Right. So, Divya sir, any before I go to, I think there's other questions. So, any other Divya sir, any views on the presentation?
Can I ask?
Sure. Yes, sir.
You see that it was said that during the testing, the hangers which were removed were not replaced, and the traffic went on without those hangers. But what did you do after the test was completed? Because my understanding is that the hangers were tested for ultimate strength. They were broken. That's what I did.
We didn't leave the hanger out for long. We took a hanger out and we had a replacement ready. So we fabricated a fully locked coil replacement. So when we took one out, we replaced it within the same night closure. We just allowed the traffic to run. And that's why it was very important to get the length of the hanger perfect so that we could replace it at the same load. We did have an 8mm cam at the bottom to adjust the load slightly, but it was very fine tolerances that we're working with to install the hanger. And then after the new hangers are currently in, and the replacement hanger, the old hangers have obviously been destructed, tested, and are no longer available.
And second is, the lengths of these three hangers were fairly limited. There are some other hangers which have much greater length. So the
Yeah.
conclusions of these three have been applied to even the longer hangars, presumably.
Yes, they can do. The reason why they can do is because the fatigue loading of these hangars are a lot higher. So what we've found is that the triangulation is causing some hangars in the bridge to be under a lot higher dead load, and also to be under a lot higher. It picks up because of the stiffness of the inclination and the triangulation effect, sort of truss effects. These hangars pick up in this location more of the load. And so the fatigue load was higher, and the overall permanent load was higher. And for that reason, if these hangars are okay, the longer hangars are okay in fatigue. Now, that doesn't get you away from the condition. If the condition is deteriorating because of lack of maintenance of the long hangars, then that is still something that the operations maintenance has to take into account. So they still need to make sure that there's no further more cracks or anything like that within the paint system or of the longer hangars. But for the inspections that the roped access guys carried out, it looked like they were in similar visual condition. They're very soon going to blast the hangars back and repaint them, and that will keep, at that time they'll have an opportunity to inspect the hangars to make sure that there's none in poor condition. And if there is one or two found in poor condition, then a one or two replacement could be accommodated rather than a full replacement of all hangars.
Thank you. Yeah.
Okay, thank you.
Yeah. So any other question? Because in the chat box I don't have any other question at the moment, and we are also running close to 7 o'clock. So any other panelists have the questions? Divya sir, Gopal. If not, then I'll pass it on to Raj Shirke sir for his concluding remarks on the presentation.
David, it was a great lecture. How we could get insight of how the fatigue affects this inclined hangars, and especially the sockets. And as per this Euro code, you have tested with for the horizontal load also with that 10 milliradian deviation. So it is a really very, very good work, and it will help the industry quite a lot. And whatever you said, that due SN code, they already published that Euro code, is it, or it is on the way? It's already published. Okay, great. So very good presentation. I congratulate you and your team for doing such a wonderful work and saving that many pounds of tax exchangers. Great. Thank you. Thank you for your time.
Thank you very much. Apologies that the IT let us down a bit, and but yeah, it was a pleasure to present to you today, and I'm glad it all worked out in the end. So yeah, thank you very much for having me.
So David, thanks a lot. We have given a very informative presentation, as our panelist has already briefed, and I would like to thank Umesh Rashirke also for giving his time. And it was a very informative presentation, and I think everybody has learned a lot many things out of it, and it was quite interesting also. So now I think with this, let me just pass on the forum to Dr. Gopal Rai for proposing a formal vote of thanks. Gopal.
Yeah. Swapnil, I'm audible?
Yes, you're audible.
Yeah, thank you. First of all, David Bishopji, it's a very fantastic, and I might translate my shairi on cable also in Hindi or English, but let me tell in English first, because Hindi will be, the cable has taught us one thing: if you are under tension, you are stable. If you are relaxed, you are unstable. So the cable is tell the truth of the life. So in Hindi I will spell, cable ने तो जीना सिखा दिया, tension है तो stable है, relax है तो unstable है. So this is one part for you, Mr. David, and really this is one of the fine subject where we are expecting that very expertise people will come, and really you have given, like, one of the old bridge, you have given a new life. This is one of the biggest charity as an engineer, as a to the nation, saving the huge cost of the bridge, and you are giving new life to the structures, like doctors, So I think a good salute to you, Mr. David. Fantastic work and fantastic to your team member and everyone. Really appreciate that part. And regarding the formal vote of thanks, let me thanks to today. Let me thanks to all the bridge engineers for such a like a subject where very few expertise are there, and there we can have a number of few speakers, and they have really done a fantastic job. So let us salute to all the bridge engineers today who have joined us, and really they have given a good number of participants on the YouTube. If I can see, there are close to 130 people have joined on the YouTube, and really a good number, and they have stood by till the lecture also. So really thanks to the speaker David G. And let me thanks to our office bearer, Director General Divte sir, then our President Vinay Gupta ji, then today's moderator Engineer Swapnil Joshi. Uh, in a tough time only we feel that how the engineer take a responsibility when the signal was bad or not able to connect. This is called best of engineering. The engineers somehow manages this thing and run the show. So this is the best forum, or you can see that Swapnil has done a very good, I think, big round of clap to the Swapnil, who has managed the things in a turbulent sea. Only then you are a good rider. Otherwise, a regular person can ride in a smooth sea also. So good, Swapnil, you have handled in a very nice way and toughest way. Good. And sometimes the God gives such opportunity to the specific people only. You are lucky among them. Good, Swapnil. Thank you very much for your moderating part. Let me thanks to this panelist, engineer Umesh Rashirke ji. बहुत बहुत धन्यवाद sir. And really, when you are sitting and asking question, I thought my PhD Viva will open up now again, and there will be a huge examination, and chances of getting pass are less. So you are prepared with the subject and you have gone through. We appreciate as a panelist you have gone to such a depth, and really good salute to you, sir. We expect such more panelists who can involve in the subject, and it always motivates the speakers. Thank you, Umesh Rashirke ji, for your kind words. Now with us, SR Tambe sir is there. After a long time, we can see the SR Tambe sir. Namaskar, sir. And really good to see you. Thanks to Dr. Harshvardhan Subbarao sir, and then Manjure Saab was also there, the executive committee member, and thanks to Goyal sir. I think before I give vote of thanks, Ruhi, can you give the leaflet of future coming event, which is very important. Let me give 1 minute there also. The upcoming event. Ruhi, can you showcase that part?
Yes, sir.
The next Friday again, we are coming with one of the like very few forum discuss about the waterproofing on the bridges. So this time we have decided that let us think like cables. Very few forum discuss. Now we want to discuss on the waterproofing also. And Mr. Pike is a well-known expert in the waterproofing. He's from USL, from Tremco, and he's one of the expert and eminent speaker. Okay, he agreed to join on 18th of September, and none other than our panelist is Engineer R.K. Goyal sir. And so we look forward to all of you to join this webinar next Friday, same time. And we hope that none of our bridge, because the waterproofing is very important from the protection point of view, and the bridge's life, durability and all. So it is a very important talk. I think all the attendee and the speaker, we request that this is a subject which is never addressed in a full-fledged way. So we request everyone to join this webinar, and it is talked by the person who has a hand-on experience. So this is the best part of that. Now, let me give a thanks to today's like Ruhi is a coordinator, Ruhi Agrawal. Thank you, Ruhi. Then thanks to Deepika Singh, the engineer from Intento, and really she has coordinated well. Thanks to Josefa. Before I conclude, on today's scenario of COVID, I'm sorry, David, might be the things will not understood to you because it will look Hindi only, but I'm trying to motivate the bridge engineers. Okay, while driving from Mumbai to from the center of the Mumbai from Mantralaya to my home, I have written something. ब्रिज इंजीनियर की जिंदगी है हर हाल में खुश रहो. ब्रिज इंजीनियर की जिंदगी है हर हाल में खुश रहो. दिस इज फॉर करंट सिनेरियो. अगर लेबर ना पास हो तो जितने पास हैं उतने में खुश रहो. अगर लेबर ना पास हो तो जितने पास हैं उतने में खुश रहो. अगर क्लाइंट रूठ जाता है, अगर क्लाइंट रूठ जाता है तो उसके अंदाज में खुश रहो. 2019 लौट के नहीं आने वाला. 2019 लौट के नहीं आने वाला. उसकी याद में खुश रहो. दुनिया में ब्रिज इंजीनियर, दुनिया में इंडियन ब्रिज इंजीनियर इतिहास बदलेगा. इस एहसास में खुश रहो. So with this note, I try to like in such a constraint, we all our bridge engineers are working, labors are less, client is not happy. Of course, Lakshmi ji, matlab the finance is not rolling, but still we are smiling, and we are trying to support each other. I know many clients are there in this forum. I'm sorry for that, but we need to be happy. If we are happy, then our bridge will be happy. Okay, so with this note, I thanks to all the people like Josefa sir, who is the IT person, and also to Vinay Gupta ji, who has really helped us in today's speaker, Engineer David. And let me, with the permission of moderator and panelists, shall we conclude today's Swapnil, shall we conclude?
Yes, you can.
We can formally conclude today's session. So thank you everyone for your participation and your valuable time. Thanks a lot.
Thank you.
Jai Hind.
Thanks. Thanks.
Thank you everyone.
Thank you,
Thank
sir.
you.
Well, sir.
Thanks.
Thank you, Subhadev sir. Thank you very much.
गए क्या सब?
Should I end?
Jai Hind.
Thanks, sir.